All right, so we're in section 8.2. So an arithmetic sequence is one. We'll talk about arithmetic sequence. Block day will talk about geometric sequence and series. One of the ones that have some special properties that let us figure lots of things out about it. So we're going to say an arithmetic sequence. The way that we're going to define an arithmetic sequence is the difference between two terms is constant. So what that means, we can write that in several different ways. If we could say that a sub n minus a sub n minus 1 equals d, and we call d the common difference. The other way that we could write that is a sub n is a sub n minus 1 plus d. So what we're saying here is to get the next term, we add d to the previous term. And some nice things happen when we have a sequence like this, and we'll be able to come up with a formula to find the nth term. We'll be able to come up with a formula to find the sum of an arithmetic series. So they behave kind of nicely. So let's look at a couple of quick examples of arithmetic sequences. We worked with some in the homework. We just didn't call them arithmetic sequences yet. So if we had the sequence 5, 8, 11, 14, dot, dot, dot. What's our common difference here? D is 3. So our common difference for that sequence is 3. How about if we had 15, 11, 7, 3, dot, dot, dot. What would our common difference be there? Negative 4. Goes down by 4 each time. So if we can find a common difference like this, that gives us an arithmetic sequence. That's how we tell if we have an arithmetic sequence, is that the difference between each successive term is a constant. So what we want to do is, knowing this, we want to come up with a formula now for the nth term of an arithmetic sequence. So let's come up with our nth term formula. So we're going to just write out the terms of an arithmetic sequence and look for a pattern in the terms to try to come up with our formula. So we're going to start with a sub 1. Our first term. A sub 2 is a sub 1 plus d. A sub 3 is a sub 1 plus d plus another d. So how could I write that? A sub 1 plus 2d. A sub 4 is going to be a sub 1 plus 2d plus another d, or a sub 1 plus 3d. So what's our pattern here? A sub n is going to be a sub 1 plus n minus 1 d. So I could write a couple more terms, and we would see that this number here is always one less than our term number. So that's our nth term formula. To find the nth term of an arithmetic sequence, start with the first term and add n minus 1 times our common difference. So that's our nth term formula. So that's going to be one of the important formulas that we come up with for an arithmetic sequence. So let's take a look at a couple different ways we can use this formula. You can find out all kinds of things about an arithmetic sequence now that we know this formula. So let's say we want find the nth term. We want to find the nth term. And we have an arithmetic sequence with common difference 5 and first term 9. So D equals with D equals 5 and A sub 1 equals 9. I'm in some trouble writing that. So we're going to, basically what we're doing here is plugging our numbers into this formula and then just simplifying. So we're going to plug into our nth term formula. A sub n is A sub 1, 9, plus n minus 1 times 5. And I'm just going to rearrange this a little bit. So A sub n is going to be 9 plus, I'm going to distribute that 5n minus 5. And I get my nth term formula for this particular sequence is 5n plus 4. So if we wanted to find any term of this sequence with a common difference of 5 and the first term 9, plug in, if we wanted the 572nd term, plug in 572 there. And we'd be able to find the 572nd term without having to count term by term. So that would be our nth term formula for that particular arithmetic sequence. Questions on what we did there? All right, let's look at another type of problem that has to do with our nth term formula. So let's say we have an arithmetic sequence and we want to find the nth term. And we know two of the terms. With A sub 5 equals 19 and A sub 9 equals 27. So we know two of the terms of this sequence, and we know it's arithmetic. Any idea how we might approach this problem? We've done some similar problems in the past.
So I would find the difference between 27 and 19 and divide it by 4.
Okay, so Justin's thinking, let's find the common difference. So we know that there's a certain number of terms between those two, so we could find the common difference. So that's one way we could do it. If we could do it that way here, what if, let's think about kind of thinking into the future. What if these two numbers were, well, I guess we could, no matter how far apart, if they were very far apart, we could still count the difference between those two and do the problem that way. So that approach would work. I was thinking of a slightly different way. So I like your idea with that one. And then once we had the common difference, what would you do with that, Justin?
Then I would just subtract down to
So subtract down from A sub 1, or that would work. Or we could plug either one of these into our nth term formula with our common difference and find A sub 1. So that would work. I was thinking of a slightly different approach. Anybody think of a different way that we can do it? Using the nth term formula. So what I'm thinking is each one of these gives us an equation. A sub 5 is a sub 1 plus n minus 1 times d. So times 4d. And that equals 19. A sub 9 is a sub 1 plus n minus 1, 8d, and that equals 27. So now I have a system of equations. And what I'm doing is essentially what Justin said, just in a slightly different way of going about it. So now I have two equations, two unknowns. One unknown is a sub 1 and one unknown is d. So what's going to be, the way I've written this system of equations, what's going to be the easiest way to solve this system of equations? What do you think we want to do, Jason? Substitution? Elimination? You think elimination will be easier? So what can we do to use elimination here? Multiply, I'm going to multiply the top one by -1 and add. So the a sub 1's go away. We could do substitution, and that's kind of what Justin was suggesting. So multiply the top one by -1 and add. So when I add those two together, the a sub 1's go away. I get 4d equals 27 minus 19 is 8. So d equals 2. And then I can plug that into either one of the equations and find a sub 1. So let's plug it into the first equation. A sub 1 equals 8, or a sub 1 plus 8, sorry, equals 19. So a sub 1 equals 11. And now I can write my nth term formula. So a sub n is a sub 1 plus n minus 1 times d times 2. And I rearrange this. A sub n is 11 minus 2 is 9 plus 2n. And I could write 2n plus 9 also, either way. So that would be my nth term of this particular arithmetic sequence. And the method that Justin suggested was kind of a shortcut to doing what I did there. So just given two terms, we can find the nth term formula of our arithmetic sequence. Questions on that problem? Now the really nice thing that we can do, really nice thing about arithmetic sequences, we can find the nth term very easily. We can find any of the terms, but we can find the sum. We can find the formula for the sum of any number of terms, and it's a very nice, easy formula. So let's take a look at that. So we're going to sum an arithmetic series. Remember, a series is just taking the terms of a sequence and adding them together. So what we want to do is come up with a formula for this sum. So what I'm going to do first is, let's say we're going to add n terms. So we want the nth partial sum. We're adding n terms. So I'm going to say s sub n, and I'm just going to write out some of the terms. S sub n is going to be a sub 1 plus a sub 1 plus d, that's our second term, plus a sub 1 plus 2d, our third term, plus a sub 1 plus 3d, that's our fourth term, plus dot dot dot, all the way up to a sub n, our last term. Now here's a nice little trick that we're going to do to come up with a formula for the sum. And the person who's credited with this is a mathematician named Gauss. And I'll talk a little bit more about Gauss in a second. So I'm going to write another version of S sub n, but I'm going to start at a sub n and go backwards. So this is going to be a sub n. Well, the next term smaller than a sub n is a sub n minus d. So I'm going backwards. And this is going to be plus, the next term smaller than that is a sub n minus 2d plus a sub n minus 3d plus dot 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 plus a sub 1. Now here's a really nice thing. I'm going to add these two together. I'm going to add these two equations together. So S sub n plus S sub n is 2S sub n equals a sub 1 plus a sub n plus, when I add these two together, the plus d and the minus d cancel each other. And I just get a sub 1 plus a sub n plus, same thing happens here, a sub 1 plus a sub n plus a sub 1 plus a sub n plus dot dot dot, and finally I get a sub 1 plus a sub n. And if I've done this for the nth partial sum, how many a sub 1 plus a sub n's do I have? N. I've done it n times. So I can write 2 S sub n equals, and if I have a sub 1 plus a sub n n times, how can I rewrite that? N times a sub 1 plus a sub n. Divide both sides by 2. So S sub n is n times a sub 1 plus a sub n divided by 2. So to find the sum of an arithmetic sequence, we add the first and last terms. Multiply by the number of terms. And divide by 2. So a very nice way to come up with, to find the sum of an arithmetic sequence. So this is our second important formula, is our sum of n, our nth partial sum for an arithmetic series. And the legend has it that when Gauss was in primary school and elementary school, his teacher would give the class things to keep them quiet while they did other things. And his teacher, the way I've heard it several different ways, but the teacher asked the class to add all the numbers between 1 and 100. And Gauss they wrote on slates, on chalkboard, and Gauss found the answer in like 10 seconds and put it down. Because he had figured out in elementary school, he had figured out this method for finding the sum. So to find the sum from 1 to 100, you add 1 and 100, multiply it by 100 and divide by 2. And so the legend has it that Gauss figured that out in elementary school. So, and he's one of the very most famous mathematicians of all time, Gauss. So this is how we're going to find the sum of n terms of an arithmetic sequence, or nth partial sum of an arithmetic series. Questions on what we did here? All right, let's look at a couple of examples of using this formula. So let's say we are asked to evaluate the sum n equals 1 to 20 of 7n plus 1. So first off, is this going to give us an arithmetic sequence? Yes, so if I write out some terms, I get 7 times 1 is 7, plus 1 is 8. My next term is 7 times 2 is 14, 15, plus, what's the next one, 22? Plus dot, dot, dot. So what's our common difference here? 7. So this is an arithmetic sequence, so we can use our nth term formula. So S sub n is going to be the first term. S sub 1 is, we decided, is 8. Plus, we want A sub 20 is our last term. So A sub 20 is going to be 7 times 20 plus 1, which gives us, what is that? 141. 8 plus 1, 41. How many terms are we adding? 20. And we're dividing that by 2. And when we calculate that all out, we end up with 1490. So we could add all of these together, or we could use our nth term formula. Questions there? All right, let's look at another one. We want the 15th partial sum of the sequence 2, 5, 8, 11, dot, dot, dot. Is this an arithmetic sequence? Yes. What is our common difference? D equals 3. We want the 15th partial sum. So we know A sub 1 is 2. We need A sub 15. A sub 15 is going to be 2 plus 14 n minus 1 times the common difference times 3. And I can calculate that out to be 44. So our 15th partial sum is 2 plus 44. We're adding together 15 terms, and we're dividing by 2. And when I calculate that out, I get 345. So this is one of the really nice things about arithmetic sequences. We can find the sum, a partial sum, very, very easily. Questions there? All right, let's look at one application problem, and then I'll show you how to do some things with the calculator. Let's say we have an auditorium. And in this auditorium, each row of seats has 2 more seats than the row before. So what is this 2 more seats in the row before telling us about our problem? That tells us our common difference. Our common difference is 2. And the first row Our first row has 30 seats. And we have 40 rows. How many seats? So we decided this is talking about an arithmetic sequence. I'm going up by 2 each time. So D equals 2. The first row has 30 seats. So what is that telling us? That's A sub 1. A sub 1 equals 30. That's the first term in our sequence. And we have 40 rows. So we want the sum of the first 40 rows. We want to know how many seats. So we need A sub 40. A sub 40 is going to be 30 plus n minus 1, 39, times 2, times our common difference. And that is 108. And now we can find our sum. S sub 40, the 40th partial sum, is 40, the number of rows, first term, 30, plus the 40th term, 108, and we divide that by 2, calculate that out, and we get that auditorium holds 2,760 seats. All right, questions? Questions there? Okay, so the homework tonight is all working with these arithmetic sequences and series. So let's take a look at how to do a few things on your calculator. So the calculator will help you with some big calculations. You will need to know how to do some things by hand. You'll have to be able to find sums and nth terms and that kind of thing by hand. You won't be able to just plug everything in your calculator. So the first thing that I want to show you is how to look at the terms of a sequence. So first I want you to go to your table set here, which is second window. And for sequences, we want our table starts. We can start this at 0 or 1, doesn't really matter. But make sure this setting is at 1. This little symbol, this means delta. The change from it means that you're going up by 1 each time. So if your table is set up that way, I can put the nth term in your y equals. So let's say our sequence is 2 to the n, so I'm going to do 2 to the x, and then I'm going to divide that by x, and I want to do, let's see, is that in here, factorial? Yes. So 2 to the x over x factorial, and I want to know what the terms of these look like. I put this in my y equals, and then I go to my table. The first term is 1, the first term is 2, second term is 1, third term is 1.33, fourth term is 0.667, etc., etc., etc. So these would be the terms of that sequence in your table. So if you want to find a specific term, you can do it this way, and I can go down, scroll down, and find our different number of terms. And you can see that gets pretty small pretty fast. Now I can't remember how many times I hit that button. There we go. So if you put your nth term in your y equals, you can use the table to look at your nth term, to look at each individual term. So that's one way you can use your calculator. Another way is we can find the sum. We can find partial sums using our calculator. Oh, I went back too far, now I got errors. So I'm going to quit out of there, So a couple of ways you can find the sum. If you have a newer model calculator, you can go to Math, 0. And you'll get a nice symbol like this. Some of your calculators will have Math 0. And you'll be able to find your sum this way. So I could say the sum for x equals 1 to 20 of 3x minus 1. And I hit enter, and there's my sum, 610. So that's on your newer calculators. Newer model calculators will have that Math 0. If you don't have Math 0, the older calculators, or if you have an 83, you can do the sum of a sequence. So to do the sum of a sequence, we're going to go to List, which is second stat. Thank you.
Yeah.
And we're going to go over to Math. And we're going to go down to 5, which is Sum. And then I'm going to go to List again, second stat. And then I'm going to go over to Options. And I'm going to go down to 5 again, Sequence. I already have something in there, so let me clear that out. So on the newer calculators, it will lead you through this. I will go through it on this one, but then I'll show you on the older calculators how you have to enter it. So let's say we want to sum our sequence. I'm going to do just 3x minus 1. Our variable is x. I'm going to start at 1, end at 20, step by 1, so that means we're going up by 1 each time. And I'm going to paste that in there. So on the older calculators, you have to do it this way. So you would do sum sequence, you do your nth term, comma x. X tells us what variable we're using. Comma 1, that's our starting point. X equals 1 to 20. And this 1 tells us the step size. You don't have to put the step size in there. It does step size 1 automatically. And then I hit enter, and I get 610. So if your calculator has Math 0, you can do your sums this way. You just enter your nth term in there and your limits, your upper and lower bounds, or you can do sum sequence this way. And any of the problems where it asks you for a sum, no matter how complicated, as long as you enter in our sequence, that way what I had entered in there before was one from the homework. It was like -1 to the n divided by 2 to the n or something like that. And I put that in there and found the sum. So our calculator, we can use the table to look at the terms of our sequence. We can use Math 0 on the newer ones, or you can always use the sum sequence, and both of those are in the list to do these things. Maybe you have questions on how to do these in the calculator, I'm happy to help you out. All right. Homework. There we go.